Now we proceed with the differentiation of inverse trigonometric functions. This is the differentiation formula for inverse trigonometric functions. In general, if u is a function of x, then we obtain the derivative of inverse sine, which is 1 over square root of 1 minus u squared, and then we have to differentiate the u. If you notice here, as I mentioned in the previous slide in the inverse trigonometric functions of graph, the inverse sine does not mean that it is exponential like this. So it is not 1 over sine u. This is the wrong concept. So in future, if you have to find the derivative of sine inverse of u, it means that it has its own formula to find the derivatives. And this is the derivative of inverse cos of u, where you will get in this form the inverse of tangent, secant, inverse of cotangent, and cosecant. So this formula will be given in your test and also in your examination. So what's most important here in derivative of transcendental function is that you have to know how to find the derivative of the functions. You don't need to remember the formula because the formula will be given. So the important part is just how to find the derivative of the function. So now let us find the derivatives of the following function with respect to x. So we have 3 questions here. You can pause this video and try to solve this question. And then I'm going to show you the solution for all these questions. For the first example, so you have to find the derivative of inverse cosecant of x squared plus 1. If you refer to the formula, given that the derivative of inverse cosecant of u is given as negative 1 over the modulus of u times with square root u squared minus 1 times with du over dx. So in our case, our u is x squared plus 1. So we just substitute u with x squared plus 1. So the solution for A will be dy over dx. The first part is we have to find the derivative of the outside function, which is the derivative of inverse cosecant. So the derivative of inverse cosecant is this formula. So we have 1 over negative 1 over u, which is x squared plus 1 modulus times with x squared plus 1 square minus 1. Now we have to find the derivative of u, which is d over dx times with x squared plus 1. Then we solve the derivative of x squared plus 1 will be times 2x. So we rewrite this. We get the derivative of cosecant inverse x squared plus 1 is equals to this. The solution for the next question is to find the derivative of inverse tangent 1 plus 4x, 1 minus 4x. Okay, first you refer to the formula to find the derivative of inverse tangent. U is given as 1 over 1 plus u square times with du over dx. So in our case, our u is 1 plus 4x, 1 minus 4x. Okay, now we rewrite this into dy over dx. The inverse tangent, the derivative of inverse tangent of u will be 1 over 1 plus u, which is u is 1 plus 4x over 1 minus 4x square. And then we have to find the derivative of u, where u is 1 plus 4x over 1 minus 4x. So this is the first equation. Okay, since this derivative involves the quotient rule, so we can assume the numerator will be u and the denominator is v. So to find the derivative of this quotient rule, you will use d over dx of u over v, which is equals to v times with the derivative of u minus u times with the derivative of v divided by v square. So you need to find the derivative of u and the derivative of v. Okay, so I write u equals to 1 plus 4x. So the derivative of u, where du over dx is equals to 4. For v, it is 1 minus 4x. And the derivative of v will be minus 4. So we substitute into the formula where v is 1 minus 4x times with the derivative of u, which is 4 minus u 1 plus 4x times with the derivative of v, which is negative 4 over v square, which is 1 minus 4x square. So the whole v is square. So we expand this, we get 4 minus 16x plus 4 minus plus 4 plus 16x, because this will be negative 16x, and then negative of minus of negative 16 will be plus 1 minus 4x square. So this will be 0. So the final answer of this derivative will be 8 over 1 minus 4x square. Now we have found the derivative of this, where the solution is this one. The next thing is substitute this into equation 1. So the final answer will be 1 over 1 plus 4x over 1 minus 4x square times with the derivative of this will be times 8 over 1 minus 4x square, or 8 over, so I put this 1 minus 4x to the front times with 1 plus 4x over 1 minus 4x square. So this is the final answer of the derivative of inverse tangent of 1 plus 4x over 1 minus 4x. For the last example, you have to find the derivative of y equals to x times with inverse sine of x plus square root of 1 minus x squared. So our derivative will be dy over dx equals to the derivative of x sine inverse of x plus the derivative of 1 minus x squared to the power of half. Okay, for first one, we will solve the first term and then we solve the second term. Then we combine these two. Okay, for the first term, where d over dx, x times with inverse of sine x, this function is involve two different functions, where this is where we can find the derivative using the product rule. Okay, for x, we represent it as u, and for the inverse sine, we will represent it as v. So, for product rule, we know that the formula is u times with the derivative of v plus v times with the derivative of u. From here, we have u is equals to x. The derivative of u is equals to 1. Or this also can be written as du over dx. And v is equals to the inverse sine of x, and the derivative of v is given 1 over square root of 1 minus u, which is x, so just substitute u with x, square times with du dx, which will be times with dx over dx, where this will be equals to 1. Okay, so we substitute into the formula, we will have u is x, v prime is 1 over square root of 1 minus x squared plus v, which is inverse sine of x, and u prime is 1. So we have x over 1 minus x squared plus inverse sine of x. Then we solve the second term, which is d over dx 1 minus x squared to the power of half. So this will be, the derivative of this will be 1 over 2. So we remain the inside function, which is 1 minus x squared to the power of half minus 1. And then we find the derivative of d over dx 1 minus x squared. So we get 1 minus x squared to the power of negative half, and the derivative of 1 minus x squared will be times with minus 2x. So this will be cancelled out. So we have negative x. Since the power is negative half, then we can bring to the denominator, which will be 1 minus x squared to the power of half. Now, we can combine these two terms to obtain dy over dx, where the derivative of the first term is equals to this x over square root of 1 minus x squared plus inverse sine of x. Then the derivative of the second term will be minus x over square root of 1 minus x squared. So x over 1 minus x squared minus x over 1 minus x squared, this will be 0. So the final answer is inverse sine of x.